All right, so function notation is not terribly difficult, but we always run into a few students that have a misunderstanding of what's going on. Really, if you take an equation, this is in function notation, you guys are used to seeing it as y equals 7 minus 3x. Function notation just gives us a little bit more information than the y equals equation does. So this is read up here, f of x. When you see function notation, it's not f times x, it's f of x. So the f is simply the name of the function. You guys might have done h for height in the past, or s for speed of something. So typically the f is our standard function notation, or it could be any letter. Your input variable they always tell you what the input variable is, and that input variable could be t for time, so you might have h for the height of something based on t time, but again f and x are our standards, and then you just write the equation behind it. So if somebody asks you to find g of 0, all you're going to do is take 0 and put it into your equation or into your function where the input variable is. So this would be, we're going right to here, 7 minus 3. And what goes in for x now? 0. So my answer then is 7. So if you write it, you would say maybe g of 0 is equal to 7. So this is why I say function notation gives us more information. When I look at it, I can see both the input and the output at the same time. If you were simply working with y equals 7 minus 3x, and somebody says, put 0 into the function, they're going to come up with y is 7, right? And if you see somebody wrote down y is 7, you don't know necessarily where they started. So that's the only reason you'd ever use function notation. You want to tell somebody what you started with and what they end with, okay? Inputs and outputs. So if I go to 7/3, 7 minus 3, and again, what goes in for the x? 7/3. What happens if you multiply by 3 and divide by 3 at the same time? Little chunga there. 7 minus 7 is 0, right? So g of 7/3 is equal to 0. We can actually take equations in the next one and plug those into the function. So you guys would have done that back in Algebra 2 with compositions, we call them. You might have had function f and function g, and somebody said do a composition. You actually took the whole equation and dropped it into the other equation. So s plus 2, this would look like 7 minus 3. And what's going in for x this time? S plus 2. So I have 7. Now you distribute the negative 3. Negative 3 times s is negative 3s. Negative 3 times 2 is negative 6. The 7 and negative 6 are like terms, so I have 1 minus 3s. So they're telling you what to put into the function, and then you're telling the output at the end. Piecewise function. So I'm going to have you take negative 2 as your input and put it into the function, okay? There's x squared plus 2, and there's 2x squared plus 2. With piecewise functions, there's usually a rule sitting there that tells you when to use each function. Because what does the word function mean again? For every input, there should only be one output. But every year, on the exam, I get 2 answers on this problem. Because students want to take the -2 and they want to plug it into both of the equations. It's very natural. You guys are so used to plugging stuff in, you know how to do it, and you end up plugging it into 2 and you write down 2 different answers. But the word function sitting right there, which should tell you there's only one answer. So, where does the -2 go? Is -2 more than 1 or less than 1 according to the rule? Is it more than 1 or less than 1? -2 is less than 1, so you should be putting it into the top equation. Right? So you only put it into the x squared plus 2. So this will look like the input variable is getting squared plus 2, so it's waiting for you to drop a number in there, and you put your -2 in there. So we end up getting -2 squared is 4 plus 2 is 6. One answer. We do not put it into the other equation. So quickly do B and C with someone sitting near you. Check your answers, and then I'll put the answer up there. All right, so if I put the answers up there, you should be getting 3 and 10. Are we good there? Questions? So 3 and 10. The idea would be, if you go to graph this, I use 1 as the cutoff, so you don't. I just represent the rule, the cutoff of the rule is at 1. So I'm going to put a dotted line there just so you can watch. I'm going to graph x squared plus 2. Now I'm only supposed to graph it when the x's are less than 1, right? So this will be on the left side of the red line. So what happens when you plug in 1 to x squared plus 2? What do you get? What? What? 3. Should I put an open dot or a closed dot there? Am I allowed to use 1? I'm allowed to use it because it's equal to. So I'm going to go to 3. What happens when I plug in 0? What do I get? 2. What happens when I plug in -1? What do I get? What happens when I plug in -2? 6. So it's going like this, right? So you're only seeing this much of the parabola because you're not allowed to go onto the right-hand side of the red line, right? You have to stop at that red line. Let's do this one in purple. What do you get when you plug in 1 to the bottom equation? 1 squared is 1 times 2 is 2 plus 2 is 4. Am I allowed to use 1 in this bottom equation? No. So we would put an open dot there, and then this is a parabola. I know it's going to continue to go up like that. So that's the first time you graph the piecewise function problem. That is why when you look at these inputs, you're getting 3 and 10. You have to make a decision. Should I put it into the green graph or should I put it into the purple